Sometime in the past year, inside a data center no journalist has toured, roughly 50,000 domestically built accelerators were lashed together and used to train a single neural network with 1.6 trillion parameters. The model is called LongCat. It was built by Meituan, the Chinese food delivery and technology conglomerate. No H100, no A100, no Nvidia silicon anywhere in the stack, by Meituan's own account. That is the anchor fact, and it lands differently depending on which story you think you are watching. The bullish read holds that export controls have already failed, that China trained a frontier model on its own chips, and that Nvidia's dominance is cracking at the foundation. The skeptical read holds that training a model is not the same as matching the machine that trained it, and that the numbers Meituan published are the numbers Meituan chose to publish. Both reads are looking at the same artifact and reaching incompatible conclusions, which means at least one of them is doing something other than analyzing. 3 disputes settle this: what the achievement actually establishes, what the benchmarks actually prove, and whether completing a training run at scale means what the bullish framing needs it to mean. By the 3rd dispute, the case that LongCat beats Nvidia has a problem it cannot fix with better marketing. The restriction meant to end China's run at frontier artificial intelligence training instead redirected it. Companies like Meituan stopped waiting for export windows and built around the embargo. That redirection is real, it is consequential, and it deserves to be called what it is. Whether it constitutes winning is a separate question, and the habit of conflating the two is not an accident. Meituan completed full training on LongCat. Not inference, not fine-tuning, but the computationally brutal forward and backward pass work of building a 1.6 trillion parameter model from scratch. The cluster involved is understood to include Chinese-designed processors from the cohort of companies that emerged or accelerated after successive rounds of United States export restrictions tightened. Training at this parameter count demands sustained, coordinated compute across thousands of nodes for weeks or months. The fact that it completed, that LongCat exists as a trained artifact, is not a press release claim in the ordinary sense. It is an operational outcome, a model that size either trains or it does not, and this one did. The bullish case makes exactly this argument. For anyone who maintained that China could run models on foreign chips but could never train them without H100 hardware, LongCat is an uncomfortable data point. The engineers coordinated 50,000 accelerators across a data center, kept the job running long enough to converge, and produced a model. The skeptics can question the efficiency. They cannot question the existence. The counterclaim is that completing a training run is not the same as completing it efficiently, competitively, or at a cost structure that generalizes to the broader industry. Every major artificial intelligence lab in the world has trained models that technically finished. The question is always the same: at what cost? In what time? With what failure rate across the cluster? And with what resulting capability per dollar spent? Meituan has answered none of those questions publicly. A training run that takes 3 times as long on 5 times the hardware is still a training run. It is not a competitive benchmark. Meituan's announcement confirmed the model's parameter count and the domestic chip training claim. The company has not disclosed training duration, total power consumption, hardware failure rates during the run, or cost per effective unit of floating point computation. The 50,000 chip figure comes from reporting that cites company or adjacent industry sources. No independent infrastructure audit has been published. The model exists. The efficiency of producing it remains, as of available reporting, unverified by any party outside Meituan. Round 1 goes to the bullish side, narrowly. LongCat's existence as a trained artifact on domestic chips is a real milestone. The round is closed precisely because it happened, and it happened well, are 2 different claims, and only the first has been established. That tension does not resolve itself when you move to the benchmarks. Meituan published performance results for LongCat, showing competitive scores on a range of language and reasoning tasks. The model reportedly holds its own against comparably sized models in the evaluations Meituan ran. If you accept those numbers without adjustment, you have a domestically trained trillion parameter model that performs at a level consistent with frontier adjacent work, which, given that it ran on chips the United States government expected to be insufficient for exactly this purpose, is a striking result. The bullish side points here and says the capability gap has been closed. The problem is that company-selected benchmarks are not rankings. This critique does not apply specifically to Meituan or to China. It applies universally to every lab that publishes its own evaluation results. Every organization chooses which benchmarks to run, which baselines to compare against, and which numbers appear in the announcement. The benchmarks that show the model in the best light are the ones that appear. The ones where it underperforms do not. Without third-party evaluation, an independent research group running LongCat against models trained on Nvidia hardware using a standardized and pre-committed test suite, the benchmark figures are the company's argument. They are not the judge's ruling. No independent benchmark comparison of LongCat against Nvidia-trained frontier models has been published by a third party as of available reporting. The evaluations Meituan released are, by standard industry practice, self-selected. Reports suggest the model performs well on Chinese language tasks and certain reasoning categories, but the specific benchmarks chosen, the exact versions of competing models used as baselines, and whether those baselines were the strongest available comparators are not documented publicly in any detail. The missing data compounds this problem. Even if LongCat matches a competitor model on quality metrics, the cost of producing that quality remains unknown, which means the benchmark comparison is incomplete in a way that happens to favor the bullish reading. Round 2 goes to the skeptics, not because LongCat underperforms. That has not been established either way, but because the evidence submitted is the company's own selection, and the data needed to independently score the comparison was never entered into the record. The bullish case rests on exhibits the defense chose. That structural problem does not disappear when the exhibit looks impressive. Now the third dispute, where the architecture of the bullish argument becomes visible. China demonstrated that it can train at frontier scale without Nvidia hardware. The 50,000 chip cluster is proof that domestic supply chains, when pushed hard enough by external pressure, can produce the raw compute necessary for work at this parameter count. The bullish side draws a conclusion. In a world where Nvidia hardware is restricted and domestic alternatives exist in sufficient quantity, the ability to train at all is a strategic capability, and LongCat proves that capability is now real. From there, a second conclusion follows in the press coverage, if not always in the careful version of the argument. Domestic chips have arrived as serious alternatives, and Nvidia's position is shakier than it looked. There is a difference between winning a race and completing it by running twice as far. If 50,000 domestic chips can accomplish what 15,000 H100 chips would accomplish, and that comparison has not been made public and cannot currently be verified independently, then the achievement is not a demonstration of parity. It is a demonstration of substitution through volume. Brute force substitution is genuinely useful in a sanctions environment. It is not efficiency. It is not competitiveness in a market where the binding constraint is cost rather than supply. The hardware is only part of what Nvidia sells. CUDA, the software ecosystem that optimizes how work is distributed, debugged, and accelerated across thousands of graphics processing units, has been developed over roughly 2 decades. It has accumulated millions of active developers. It is deeply embedded in every major artificial intelligence framework. Domestic Chinese accelerators ship with their own software stacks, some of which have made real progress over recent product generations. None of them have closed the CUDA ecosystem gap. Training LongCat required Meituan's engineers to work around, compensate for, and in some cases rebuild portions of the software infrastructure that Nvidia customers receive as a baseline. That engineering cost is not visible in a benchmark. It is visible in how long the project required, how many engineers were deployed, and whether any other Chinese company can replicate the result without building the same internal capability from scratch. Think of it this way: a construction crew with twice the workers and 3 times the time can finish the same building as a smaller, better equipped crew. The building exists either way. The larger crew is not more capable. It is more expensive for the same result. And if the client needs the next building faster or cheaper, the equation does not improve on its own. 50,000 chips finishing a training run says the building got built. It says nothing about whether the crew can compete on the next contract at comparable terms. CUDA's development timeline and ecosystem scale are well documented in industry reporting and in Nvidia's own public materials. The comparative efficiency of domestic Chinese accelerators versus H100 chips at the training workload scale Meituan used has not been published by Meituan or verified by any independent party. Reports from researchers who have used Chinese domestic accelerators describe software compatibility challenges, including gaps in automatic differentiation support, distributed training optimization, and debugging tooling. The severity varies by chip vendor and has reportedly improved over recent product generations, but the gap has not closed to a point where external researchers describe the experience as equivalent. The claim that LongCat's training required significant internal software engineering to compensate for ecosystem gaps is consistent with what has been reported about large-scale domestic chip training projects broadly, though Meituan has not published specifics about its own software development effort. Round 3 goes to the skeptics, and it goes clearly. Completing a training run on 50,000 chips does not establish that those chips are competitive with the alternative at any given unit of useful output. Economics and software overhead, not the existence of a completed run, are the axes on which the claim that this beats Nvidia must be argued. On those axes, the evidence submitted so far does not make the case. The software ecosystem gap is not a column in a benchmark table. It is a compounding disadvantage that accumulates across every project that follows. Every team that has to rebuild what Nvidia customers inherit, every engineer month spent on infrastructure that does not directly improve the model. Before the verdict, 3 challenges to that ruling deserve honest weight. Efficiency, gaps close. The first generation of domestic Chinese accelerators was measurably less capable than contemporaneous Nvidia products. Later generations have reportedly closed portions of that gap, and the training infrastructure that Meituan built to run LongCat does not disappear after the job completes. It becomes the foundation for the next model, and the one after that. If the trajectory of improvement holds, the efficiency argument weakens over successive iterations. What would change this verdict? Independent benchmarks showing domestic chip training efficiency approaching H100 parity on standardized workloads across successive product generations, published by parties with no stake in the outcome. The software moat is real, but not permanent by definition. China's artificial intelligence software ecosystem, including frameworks developed domestically and adaptations of open-source tools, has been the subject of serious engineering investment since export restrictions began tightening. Some researchers report that recent domestic accelerators are meaningfully easier to work with than earlier generations. The gap may be overstated as a structural permanent advantage if it is, in practice, a diminishing one. What would change this verdict? Published developer adoption data, accounts from external researchers describing comparable ease of use on production workloads, and third-party software compatibility audits for the chips used in LongCat's cluster. The cost comparison the skeptics demand may be moot in a sanctions environment. If H100 hardware is simply unavailable at any price, the relevant question is not which option is cheaper per unit of floating point computation, but which option can actually be procured. In that frame, 50,000 domestic chips that complete the training run are not competing on efficiency. They are the only option on the table, and being the only available option is a form of prevailing by default. The economics argument implicitly assumes a market in which both options exist. What would change this verdict? If export controls ease and the market reopens, at which point the cost comparison becomes relevant again and may cut differently than the current framing suggests. Each of these challenges is live enough that Round 3's verdict is provisional rather than permanent. The round goes to the skeptics on current evidence. The evidence that would reverse it is, at least in principle, producible. That matters for what the next 5 years look like. LongCat is a resilient story. That is not a consolation prize. Resilience in the face of sustained export controls aimed specifically at preventing this outcome is a strategically significant achievement, and the bullish side is right to market. What it is not, on current evidence, is a story about surpassing Nvidia. Beating Nvidia means training at comparable quality, for comparable or lower cost, with comparable or lower engineering overhead. None of those comparisons have been made publicly, and the ones that can be inferred from available information do not favor the bullish reading. The confusion between the two stories is not accidental. A resilient story demonstrates that pressure is being absorbed and redirected. A supremacy story licenses a different set of conclusions about where the technology competition stands and who is winning it. The distinction matters enormously to investors, to policymakers, to engineers deciding where to build careers, and to anyone trying to understand whether the export restriction strategy is working. Meituan trained LongCat on domestic chips. That is the established fact. That the fact gets narrated as evidence that China has surpassed Nvidia is an editorial choice, and the evidence does not yet support it. The export control that was supposed to settle the question of whether frontier training requires Nvidia hardware, instead produced LongCat. That is the recurring pattern. The restriction reopened the question it meant to close, and the round that should have ended China's run at this capability level redirected it instead. LongCat is what that redirection looks like when it works. What it does not yet look like is the finish line. LongCat 1.6T is the most concrete evidence currently available that domestic chip training at frontier scale is operationally possible. It is also the most concrete evidence that possible and competitive are not the same word, and that the distance between them is where the real contest is being run. Every subsequent model trained on domestic hardware will either narrow that distance or confirm it, and Meituan has now built the infrastructure to find out which it is. The export controls did not stop a trillion-parameter model from being trained on Chinese silicon. They ensured that when it happened, the achievement would be real enough to be mistaken for a victory. Which round do you think the hype cycle consistently gets wrong? The one where a completed training run gets treated as proof of parity, or the one where the software ecosystem gap gets dismissed as a temporary inconvenience that engineering ambition will close on a convenient schedule? The answer changes what you think the next 5 years of this contest actually look like. Leave the argument in the comments. And if you want the round scored as carefully as the headlines are written, subscribe and turn on notifications, because more of these fights are coming, and most of them will be called incorrectly on the first day.